We are picking up where we left off yesterday in section 5.3, continuing our notes for normal distributions finding values. We're going to start off transforming a z-score to an x value. We have our equation to find a z-score, x minus the mean divided by the standard deviation. If instead I chose to solve for x, meaning I wanted to get x by itself, I'd start out by multiplying both sides by the standard deviation. And then I would add the mean to both sides. That would give me x is equal to the mean plus z times the standard deviation. So we can solve for essentially any variable in there, but this is going to allow me to take a z-score and change it to an x value. So let's try one of these problems. A vet records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. Find the weights, which means I'm solving for x, corresponding to the z-scores of 1.96, negative 0.44, and 0. So starting with the first one, I'll plug into my equation. X is equal to the mean plus the z-score times the standard deviation to give me 12.92 pounds. X is equal to the mean plus the z-score times the standard deviation. And the last one I could solve, but I could also know that if my z is 0, then that is going to be my mean, because that's where my graph is cut in half at the mean. But if you didn't remember that, you could plug it in. And you get 9 pounds, which is the mean. So each of the z-scores, 1.96, corresponds to 12.92 pounds. The z-score of negative 0.44 corresponds with 8.12 pounds, and the z-score of 0 corresponds with 9 pounds. Finding a specific data value for a given probability. So we're going to use the normal distribution. We're going to sketch the graph. We're going to find the z-score that goes with the given area. Then we can solve for the x and interpret our results. Scores for the California Peace Officer Standards and Trainings Test are normally distributed. So meets this. We can continue with a mean of 50 and a standard deviation of 10. An agency will only hire applicants in the top 10%. That sounds like my area has to be in the top 10%. What is the lowest score you can get and still be eligible to be hired by the agency? So first, I want to go ahead and sketch my graph. So top 10%, that sounds like it's going to the right, which means this area would need to be 10%. Okay, 10% means that 1 minus my area, since it's to the right, gives me an area of 0.9 to look on the chart. So when I look at the table, I'm looking in the middle of the chart at 0.9, and the closest to that is 0.8997 for a z-score of 1.28. And now I'll solve for my x to figure out what the lowest score I can get to still be hired. X is equal to the mean plus the z-score times the standard deviation to find 62.8 to be my lowest score to still be hired. In a randomly selected sample of women ages 20 to 34, the mean total cholesterol level is 188 milligrams per deciliter with a standard deviation of 41.3 milligrams per deciliter. Assume the cholesterol levels are normally distributed. Find the highest total, and you can still be in the bottom 1%. I'm looking for bottom 1%. So if I were to graph it out, I'm looking for my area here to be 0.01 or 1%. Okay, I want the highest to still be there, so I'm looking for the z-score right there. So in the back of the book, since it's to the left, I don't have to adjust the area at all. I'm looking for the number that is closest to an area of 0.01, and that's going to be 0.0099 at z equals negative 2.33. So now I'll plug it into my equation. X equals my mean plus the z-score, times the standard deviation. To find my X is 91.77 milligrams per deciliter. So that's the end of section 3. I will post an assignment on Google Classroom. You completed 1 through 16 yesterday in class. Now I need you to complete 17 through 35 and turn it in on Google Classroom. That will be 5.3 completed. So when you're finished, it will be 1 through 35 all.